Okay, so in this, they're not going to tell us whether it's a linear sequence or a geometric sequence. They're just going to give us a relationship between the first term and all the other terms. Okay, so sometimes these are called recurrence relations. Okay, so a recurrence relation is when they're giving you the way to get the next term by doing something to previous terms. Okay, so for example, they might say t of n plus 1 is 2 times tn plus 2. Okay, and then they'd have to tell you maybe that t1 is 2. And then you can find t2. Okay, when n is 1, it would be 1 plus 1, so that would give you t2. And anywhere here you have n, you're putting in 1, so it would be 2 times t1. Okay, so I'll just do an example of a few of those. Okay. Okay, so write out the first 5 terms of the sequence defined by t of n plus 2 is t of n plus 1 plus tn. Okay, and they're telling me t1 is 1 and t2 is 2. Now, I have t1 and t2. If I want to get t3, what do I have to let n be? How would this become t3? Yeah, perfect, thank you. So for t3, this would be t of 1 plus 2. So n is 1. Okay, so that would mean t of 1 plus 1 plus t of 1.
So is the 2 like just plus the n and not the tn?
Here, yes, this is t of n plus 2. Yeah.
Okay.
So what you end up with is t3 is given to you by doing t of 1 plus 1, which is t of 2, plus t of 1. T of 2 plus t of 1. Now we know t of 2 is 2 and t1 is 1, so t3 is 3. So now I have t1, t2 and t3, and I need the first 5 terms, so I need to get t4. Now if I want t4, what's n? So this bit here needs to be t of 4. So what does n become?
2.
Yeah, lovely. So that's 2 plus 2. And here I have t of 2 plus 1 plus t of 2. Okay, so that's telling me I need t3 plus t2. Okay, t3 we just found out is 3, and t2 is 2, so that's 5. And you're going to do the same for however many terms they want. So they want t5. So in order to get t5, I must be doing t of 3 plus 2, because 3 plus 2 gives me the 5. So here I know n is 3, so that's 3 plus 1 and 3. So that's t of 4 plus t of 3. I found t of 4 there, it's 5. And t of 3 there is 3. Okay, so just lay it out really clearly. Figure out what your n needs to be and then replace that number in your formula. Okay, anywhere you see n, you're putting in your 1, and in this case it was 2, in this case 3. Okay, I'll just do another one like that. Tell me when I can clear the board. Are we good? Okay. Okay, write out the first 4 terms of the sequence defined by t of n plus 1 is 2 times t of n plus 1. Okay, so to get the next term, you do 2 times the previous term and then you add on 1. Okay, I need the first 4 terms and I have t1 already, so I have the first term. So I'm looking for the second term. So I'm looking for t2. To get t2, I know this n must be 1 plus 1, okay, because that will give me t2. So that means n is 1, so 2 times t of 1 plus 1. So that's going to be 2 times whatever t of 1 was, plus 1. 2 ones is 2, plus 1 is 3. And you want the first 4 terms, so you're just going to do that for t3 and t4. Okay, so t3 is going to be t of 2 plus 1. So anywhere you see tn, you're now saying t2. So 2 times whatever t2 was, which was your answer there, it was 3, add on 1. So 6 plus 1, 7. And then for t4, if you want, you can just, we know that to get the 4th term, we're doing 2 times the term before that and adding on 1. So it's 2 times 7 and add on 1, okay? But just to keep going using our formula, to get 4, it's going to be 3 plus 1. So that's 2 times t3 plus 1. So that's 2 times the previous plus 1. So your answer is 15. So the first 4 terms are 1, 3, 7 and 15. Is that alright? Okay, and the next thing I want to have a quick look back at is quadratic sequences. So do you remember quadratic from junior cert? Kind of, yeah. Can I get rid of the board? Okay.
Yeah.
Thank you. So quadratic and cubic patterns. Okay, so if you think about this pattern of numbers or this sequence, if you're not sure what type it is, we always do our loops. Okay, so that's 10, 17 to 31, or 31 take 17. Okay, so it's not linear because the first difference is not constant. So let's see. So that's 4 and that's 4. So it's quadratic. Second difference is constant or is a constant. Okay, and in quadratic you learned something, and it was that 2a equals d. I'm just going to call it difference today. So it's a quadratic. Your quadratics are normally ax squared plus bx plus c. In this case we're in pattern, so an squared plus bn plus c. Okay, so it's just like your quadratic formula, but instead of x's you've n's. That is your general term for a quadratic, an squared plus bn plus c. And you have to learn off that twice the coefficient of a is the difference, okay? Or 2a is the difference. In this scenario, it would be 2a equals 4, so a is 2. You'd have already that coefficient of n squared. That would be 2, okay? After that, if you remember, we used to fill in T1 and we'd fill in T2 and we'd do simultaneous equations. Okay, now I'm just going to do an example of that. This is what I want you to remember, these two things. Really important. Okay, so example 1. Can I get rid of this?
Yeah.
Thanks. Okay. Okay, a mosaic arrangement is constructed on the floor as shown. Find the number of tiles needed for the 30th pattern. This is on page 356 of your book, okay? So there's your pattern. Find the number of tiles needed for the 30th pattern. So to get the 30th pattern, you're going to have to get a general formula. Okay, and we'd need to figure out what's happening. So the best thing you can do is write out your pattern of numbers. Okay, so my pattern of numbers is 1 square, 3, 6, and then 10. Then you're going to get your differences. Okay. So it's not linear, it is quadratic. You all right with that so far? Okay, from there you're going to write out your general term of a quadratic pattern. So Tn is an squared plus bn plus c, and 2a equals the difference. So immediately I can get this 2a is equal to my difference, which is 1, so a is a half. Okay, so my general term becomes a half n squared plus bn plus c. Now, to get b and c, you need to fill in some values, okay? So T1 and T2 is what you're going to fill in, okay? Because we know T1 is 1 and T2 is 3, don't we? So T1 is 1 and T2 is 3. Now, instead of n, I have 1. So instead of n here, you're going to put in 1. A half 1 squared plus b times 1 plus c. And we know when we fill in 1, my answer is 1. And on this side, you're doing the exact same thing except it's T2. So anywhere you see n, you're putting in 2. A half 2 squared plus b times 2 plus c. And you know when you fill in 2, your answer is 3. So you get a half plus b plus c is 1. B plus c is a half. Okay, just bringing that half over and making it a minus. And then here, 2 squared is 4, half of 4 is 2, so 2 plus 2b plus c is 3, 2b plus c is 3, take 2, which is 1. Now that you've got those, you're just going to do simultaneous equations with those two, okay? b plus c is a half, and then 2b plus c is 1. Draw a line. I'm changing all my signs. I'm going to actually change the ones on the top. Okay, 2b take b is b. The c's cancel. And 1 take a half is a half. And then to fill it in, pick one of the lines. b plus c is a half. I have b already. A half plus c is a half. So c must be 0. So last thing, write out your general formula. A was a half, B was a half, C is 0. So back here, A was a half, n squared plus a half, n plus 0. Okay, now the question actually asked me for the 30th pattern, so I need to do t of 30. So that's a half 30 squares plus a half 30. Okay, and when I do that I get 465.